Welcome friends to this series of learning Google Cloud Platform database series. So in this particular lecture, we will see how we can create the Cloud SQL database, and mainly we will focus on MySQL database in this particular lecture. And we will see in-depth knowledge of everything like how we can create the Cloud SQL database to uh, access it publicly, or how we can create a private Cloud SQL database, whether we can connect to that SQL privately in Google Cloud environment itself. Also, we will see how we can maintain the database, how we can patch the database, how there are other options in depth, each and everything in this video lecture today. So stay tuned. It's a very important and must database to watch for every professionals in any field. So stay tuned. So friends, this is our Google Cloud platform, and we have come to the Cloud SQL page. Either you can navigate through the search bar, searching this SQL, or you can go to this hamburger menu and go to the SQL. You will be landed to this Cloud SQL page. So Cloud SQL offers a fully managed database services for MySQL, PostgreSQL, and SQL Server, reducing your overall cost of operations and freeing up teams to focus on innovations. So it's a completely fully managed databases for MySQL, PostgreSQL, and SQL Server. And you no need to hire a database administrator, and you can peacefully run these Cloud SQL, and you can focus on your innovation. But if you have the database administrator in your team, it's definitely better for your environment. They can have in-depth knowledge how you can administer these Cloud SQL. So it's up to you. It's depending upon the business requirement. But what Google is suggesting, that you can worry free if you are having these Cloud SQL. Okay, so let's get started. First and foremost thing, that we can click this create button, and there you are having the choice like whether you can go for MySQL, PostgreSQL, or SQL Server. Now, recently Google Cloud has introduced this AlloyDB, which is basically extra managed version of PostgreSQL. Why I'm saying this extra managed? Because this is the uh, cloud-friendly Postgres version of this PostgreSQL, and it will support this AI ML powered management, and as well as it is having industry-leading 99.99% of SLA, and it can handle more efficient analytical and vector queries, and as well as the normal OLTP systems, which is 4x faster than normal Cloud SQL, PostgreSQL database. So, well, I mean, we are not going to focus on PostgreSQL or SQL Server in this particular video. In the subsequent lecture, we will go in depth of these databases too. But for now, we are interested on MySQL. So choose MySQL, and that will open the form how you can configure your Cloud SQL database. So first and foremost, here they are providing you two options. So basically, Enterprise Plus and Enterprise, the basic difference is that it is actually production scaled Enterprise Plus configuration. And if you choose this configuration, it will auto-populate a couple of fields over here as per your business need. So it will give you like, 35 days point in time recovery window. Whereas if you choose this enterprise, you will have only 7 days point in time recovery window. Don't worry, we will come up all these points one by one. And this is basically near zero time instant scale up. Definitely, it will take some time. to scale the databases, but that's completely fine. I mean, we can go one by one. First of all, we will see what are the enterprise configuration is there. Now, there is a edition preset, like, I mean, you can run the production on enterprise version. You can have production, development, and sandbox. So basically, these are the predefined templates, you can say. Like if you choose production, then it will set a instance with 8 vCPU and 32 GB of RAM, having 250 GB of storage with high availability. So, for example, if we choose this one, you can definitely see that automatically multiple zones, high available options is chosen. And you can go to the storage and you can see automatically 250 GB storage capacity is selected. So basically, it's a kind of a template. That is what I just told you. If you specify, for example, sandbox, which is basically 2 vCPU and 8 GB of RAM, you can see that sandbox configuration is applied, and you can see that automatically single zone, because it is suggesting that you can have single zone database server, and as well as you can see that 10 GB storage capacity is automatically selected. So don't worry, we will go one by one. So doesn't matter what you basically choose. So maybe we can choose development one, which is having a blended flavor. So here we are going to specify the database version. So database version, we have chosen the default one, but there is 5.6, 5.7, and 8 versions can be selected. So basically, we need to provide an instance ID, and we can provide the instance ID like MyDB. So MyDB, we can specify the instance ID, and then we can either give the password or we can generate a password. So that is basically uh, a, a complex alphanumeric character. So maybe we can copy this one and we can just keep it in a safe location, that what is our password, or you can provide your own password and to avoid these auto generation one. Okay, so we have for now provided the database engine name, user ID, and password. Now, this password is basically the password of root user. So you can see that set a password for the root user. So whenever you are going to connect to this database, you specify this password for the user of root. Now here, let first create a single zone database. So basically, this database will be uh, zonally available in a single database instance. So it will not have any HADR environment, high availability disaster recovery configuration. So once the database will fail, so for any unfortunate event occurs on this particular database, you will have no other option to run the database from other instance. So you have to restore the database back from the last known image, and then only you can run your production scale or the development scale in our case. So there is no other option to failover. So if we choose these multiple zones, that is basically the high available. So same database will be hosted in different zones. One database will be primary and the other ones will be secondary. So there will be a pair of database instance will be created. So there you need to specify the primary zone and the standby or secondary zone. So primary zone, you can manually specify, for example, US Central 1A and US Central 1B for the secondary zone. But if you think that you need to provide the same zone for these multiple zone high availability database cluster, you will not be allowed to. So for example, if I choose Central 1A, you can see that primary and secondary zones should not match. Okay, so maybe I can keep it as any secondary zone, or maybe we can hardcodely specify that I need 1B as a secondary zone. So if in the worst case scenario, if one B standby, if this US Central 1B zone is unavailable for some reason, the standby will not be created or can run if the primary zone got crashed. So that's the reason you can specify any uh, other than this primary zone. For now, I'm just going to select the select zone as a standby. There is no standby will be created, so it will be a stand-alone database with having one zone uh, availability. So basically, only primary database will be there. There will be no standby database. Okay, so then we need to specify the machine configuration. So as we have selected this development one, and this development database is chosen as 4 vCPU and 16 GB of RAM. So we can specify our the vCPU and memory as per our requirement. For now, I can choose these 2 vCPU and 8 GB, which is sufficient for this particular demo. And we can exclusively enable these data cache if we go for Enterprise Plus Edition. So as we have chosen the Enterprise one, we did not able to choose this data cache. So basically, when you choose this data cache, so whenever the same query is being fired, it can reduce the latency of the read and it can improve the performance. So it's kind of a extra layer of memory cache, which is basically um, will be placed in front of the database. So whenever the data is being asked and if it is in the cache, it will be delivered from the cache. Otherwise, the data will be pulled from the database and it will be populated in the cache. So whenever the data will be provided from the cache, definitely the performance will be improved and the latency will be reduced, specifically the read latency. The same is for write. So whenever the write is being performed in the database, it will be written in the database and then the same data will be written in the cache as well. So the next time when the read will perform the same data, so it will be delivered from the cache. So basically this feature can be available and it is only available in the Enterprise Plus edition. So we have no other choice, so we cannot enable this one for now. So later we can see. So we can use either SSD and HDD. So SSD definitely is the popular choice because of the low latency. And you can see the cost is basically for $0.16 per hour if we choose for SSD. But if we choose the HDD, definitely you can see it comes to 15 cents. So 1 cent will be saved each hour if you choose for HTTP, but definitely will have the higher latency and the low performance. So similarly, you can specify the storage and by default, it just choose these 100 gigs as we choose the configuration of the development. But you can definitely go for 10 GB or 20 GB or whatever you need. But one thing you should notice that whenever we increase the uh, storage, definitely our price is high. Same time, our IOPS will be higher if we go for higher capacity. So higher capacity improves the performance. It's not only the storage, it is just going to add the storage and our capacity of the database will be higher. It also improves the performance. So up to the limit set by the machine type, capacity can be decreased later. So this is the second other important point. So for example, if we choose, for example, say 100 gigs for now, and if we latter can understand like, okay, fine, I mean, we are having only 10 gigs of storage and the rest of the 90 gigs is not needed. So let's go for 20 gigs or 10 gigs. It is not possible. So you can, whatever you are going to choose at the first time when the database instance is going to be created, you can automatically increase the storage, or you can increase it manually but you cannot reduce the space. So capacity can't be decreased later. So it's a very, very much important point. And just just see these read and write throughput. So for example, we have chosen these 20 gigs, and you can uh, see this read throughput is 9.6 and the write throughput is 9.6 to 240. And if we just go, for example, 250 GB of storage, you can see instantly these read and write cap throughput and the IOPS instantly got increased. So basically, it's not only the storage, it is also the it is also the limit that you are going to put for your database performance as well. So both IOPS and throughput is increased if you are having the higher storage capacity. So for example, let's for this demo, we are fine with this 10 GB storage capacity. We are fine with that. And we are just going to keep this as enable automatic storage increase. So whenever there is more need for the space, it will automatically increase the storage capacity. Okay. So next, go to these connection. So by default, this public IP is enabled, but it is a big no if you really want to have this database to run in cloud Google Cloud platform, because you should not traverse your database traffic through internet. So public IP means that you are going to assign an external IP address for your database instance, and uh, through that IP address, you are going to connect to your database instance. Okay, so this is the private IP. If you are just having this private IP, your database can only be used within this Google Cloud network, and whoever can access that particular internal IP address, only that particular instance can communicate with this database. So anyone outside the Google Cloud environment cannot access your database if you go through this private IP connection. Okay. But for this particular demo, first we will create the public IP, and then later we will create another instance uh, which will have the private IP, so we can cover both. Okay, so for example, first we will see what are the things, because it's not only the selecting this option in public IP can you can able to access this database. So let's click this public IP, and now you need to authorize our network. Okay, so otherwise you cannot access this database externally. But for now, let it blank, and we will see how we can configure this one. Okay, we can definitely add a network, and we need to provide some network IP address and all those things. We will come to this later. Okay, so first see, I mean, how we can connect to this database through public IP. So as it is the public IP, so there is no need to enable the private part, because we are not selecting the private IP as well. We can select both as well. Okay. So if we choose the private IP anyway, I mean, you can enable this private path so that your database can be securely privately connected through some different Google Cloud services like BigQuery and all. And next, this is coming for the data protection. Now, if you are going to have these automatic backups and point-in-time recovery, you should enable these automatic daily backups. And automatic daily backups and enable point-in-time recovery will have 1 to 7 for Enterprise Edition and 1 to 35 for Enterprise Class Edition. So for now, if we disable these automatic daily backups, you can see instantly this point-in-time recovery got disabled too. So to enable these point-in-time recovery, we will have to select these automatic daily backups. Okay. So for now, let's enable this one and we will see how we can use this point in time recovery. Now, there is another checkbox which is basically enable the deletion protection. So if you click this one, you cannot delete the drop the database, and you have to specifically uncheck this box to delete that particular database instance. So basically, this is an extra layer of protection for the accidental deletion of the database. So for now, we are just not going to select this one, and we are okay that we are going to drop this database, and no matter if it is deleted accidentally. So maintenance is basically the maintenance type. Maintenance typically only takes place once every few months. So whenever there is a new patch we released or there is some uh, need of emergency patching from the service providers, so this will be applied automatically. And this is where it is actually said as completely fully managed, because you don't need to bother about the patching, how the patching needs to be done, in which order this patching will be needed to be implemented. You don't need to worry about that. And Google Cloud will basically do on behalf of you. But what you need to do, you need to specify the maintenance timing. So you are going to say that the week to apply the maintenance when a new version is available, whether it is week 1, 2, 5, or any. Okay. So you need to specify the week and maintenance window. Like you need to specify the time or date. Like, I mean, it should be Saturday, Sunday, which Saturday of. So, for example, if I say Sunday, so first week, uh, if the Sunday, and this is the time like 4 a.m. to 5 a.m. Indian Standard Time, you can allow this database to go into an outage mode, and you can go ahead and do the patching. So we are using this single standalone database having no standby. So if we can see that we have used the single zone database, and the single zone database basically having no standby. So whenever you are going to have this maintenance, you cannot use the standby as well. So basically, whenever this patching will be done, you will have some outage experience as well. So you can specify this timing as per your business requirement. Okay. So next is flag. Flag is something that specific to the database. For example, we are having this MySQL database, and here all these particular parameters, these database configuration parameters are there for specific MySQL database. So you can, if you need any kind of configuration to do for these database, you can definitely go ahead and put those values over there. For example, if we say bulk insert buffer size, and you can specify the buffer size that you actually need, I can put 1,000 or 10,000. So it is also provide you the buffer size for the insert. You can specify from 0 to some value, which is specifically for MySQL database, which is 8 version 8. So the maximum allowed value for MySQL database engine 8.0, you can specify the amount over here. And you can simply add one or more database configurations as per your need. Okay. This query inside is something that is provide the extra granularity of visibility of your database. So query insights helps you detect and diagnose performance issues in your instance by examining queries using both historical and near real-time data. And you can enable it to understand database load, identity slow running queries, and gain visibility into apps that connect to this instance. 7 days telemetry is free of cost, but if it goes beyond that, you will be charged accordingly. So you can specify the um, query inside, and what kind of query inside you need to enable, you need to specify as well. So for example, I need to learn like from where this particular connection request is coming to the database instance. So I need to store the client IP address in that case. So if I want to learn like, which tagged applications are making the requests, so I can group that particular data and run the metrics against that. So store the application tags. And if I need to choose the default limit of the query length, then higher the query length requires more memory, definitely, and we can customize our query length. Okay, so we can click this customize query length. So it is basically changing the default limit on query length. So it can be up to 4,500 bytes and down to 256 bytes. So higher query length requires definitely more memory. So you can definitely enable this one. And you can also set the maximum sampling rate. Now, maximum sampling rate, whenever depending upon your database load, a maximum of 5 executive query plan samples are captured per minute across the database of the instance. So you can increase the sampling rate is likely to give more data points, but it can have some performance over it. So whenever you are setting these 5, that means you are basically having 5 queries to send for sampling, and it is recommended to have to be like 5 to 6 or something like that. Having too many sampling, like I mean, if you are just sending 20, for example, then it will be overhead on the database itself. So eventually, you are going to impact the database when you are going to monitor the database. Labels basically is kind of a tagging. So you can add label like anything, any key value pair, like you can say like environment is a dev or test. So this is something that will be tagged for this particular database. So we are fine, whatever the configuration we have done. So let me review once. So we are having these 2 vCPU. So basically, we are having MySQL 8 database engine, and we are saying that we need a standalone single zone database, which will be hosted on US Central 1A. We can specifically mention that US Central 1A, I need this database, or we can specify any. So any zone will be picked up to create this particular database. And we have specified that we're going to create a database with 2 vCPU, 8 GB of RAM. We need SSD as storage. We are fine with 10 GB of storage capacity. So we are fine with the associated IOPS and read throughput, read write throughput. But we have enabled the automatic storage. So whenever there is a more need of storage, it will be automatically added. We have mentioned that public IP, I need to create it as I can access this database from external world. I no need have any private IP associated with that one. And as well as we don't have private IP, so it cannot be accessed to private path. So we are going to say that we need the daily backups. So every day around 1:30 p.m. Between this 1:30 p.m. and 5:30 p.m. the database will be backed up. We need the point in time recovery, so we will come to know what exactly this point in time recovery is. Don't worry about that. But we are saying that we can backtrack to 7 days to recover the database. So we have provided these 7 over there. We are fine. We can go this database dropped without having any ORI. So we did not enable these enable deletion protection. For maintenance, we said that every first week of a month, every Sunday of the first week of the month between 4 a.m., 4:30 a.m. to 5:30 a.m., we can go for this maintenance. So whenever there is a patch or anything new, security patch is coming to the picture, Google can automatically apply those patches within this time frame. We are saying that we need a specific database configuration parameters to change, and that configuration parameter is bulk insert buffer size, which should be set as 10,000. We need the query inside, which is basically 7 days telemetry. So it is basically uh, the extra performance diagnosis issues that will be captured in uh, cloud logs, and you can see that 7 days telemetry is completely free. So we are going to enable query insights, and maximum sampling rate we have provided 5, and we have tagged this as environment test. So let me create this instance, and we will try to connect to this instance from external world. So I have clicked this one, and it will take some time. So typically it takes like 5 to 6 minutes. Uh, so let's see. And once the database will be created, we will be back. Let me pause my video, please. All right. So after a couple of minutes, so the database is created. Now let's see. What are the things have been created for us? So basically, we got one public IP address because we enabled the public IP. So this public IP will be needed to connect to the database. And also, we noticed that we have created the root user ID and password. So we will use that thing. We got a service account and as well as some operation logs. So that's basically first saying that the database was created. And once the database was created, first and foremost thing it took one backup. So the first backup should be created, and as well as you can see the database flag that we have enabled and the labels we have done was completely available. Now, this is not highly available database as we have selected the single zonal configuration for the database. So this is what we have we got. So this is under the overview, and we can go to Cloud SQL Studio where we can really interact with this particular database. We haven't created any database, but there are 4 databases are created by default, and as well as we can see that a root that can be used to connect to the database, but unfortunately we can't use the root because root is not supported. So we need to create one user to use the Cloud SQL Studio. As well as system insights, we haven't any um, events because we just created the database. If we keep on doing some activity, probably we will get some metrics over there. So in this query insight, we can come to know that which particular queries are running and which are the top queries. So we don't have run any queries, but you can see some queries. Those are run by this MySQL engine. So you can see a couple of queries coming in the top section. And you can have these database load for each queries respected. So once we run a couple of queries over here, we can find some insights on these query insights. So in these connections, basically, we will come to know what is the public IP or private IP, how we can connect the database, and we will have uh, the networking section where we can easily enable these private IP or we can disable the public IP in future, and we can add the network to whitelist the clients, as well as we can have the security. So over here, our security SSL. SSL is basically the how the data is encrypted during the transmission. So when the data is being moved, whether it is secured or not. So when we have allowed the unencrypted network traffic, this SSL is not required. But if we have a higher security, in the upcoming lecture we will see, we will allow only SSL connection. So if we do so, then this particular database can only be accessed if we made some SSL encryption through this connection. And we need the CA certificates if we allow the SSL connections only. So we need to manage the certificates. We can download the client certificate and connect to the SSL. So right now we don't have the SSL connections. We don't disallow the unencrypted network traffic. So all the unencrypted network traffic can traverse to this database. So this was actually the connections. So mainly we are interested on this public IP address. So here we are going to use this public IP address to connect to this database. So if we go to this user section, we can see that only user root is there. So we can add the user, and it is very easy to provide the username and the password. Let's provide some user, say user one. PASSW 0 or D. And we can say allow from any host. And we can also restrict the host by IP address or IP range. So for now, we can allow any host. So any host can use this user ID and password to connect to this database. Apart from that, we can use this cloud IAM as well, so that you can directly connect to the database through IAM. So we will come to this in subsequent lectures. For now, we can create one user named user1 and password. All right. So once you have created these users, even you can go to this Cloud SQL Studio and connect to the database with user1. You can provide this password to get into the system. We will come to these things later, but let us navigate all these databases. So we don't have any database till now. By the default, databases were created by these MySQL databases. Backups, we only have one backup which was being taken during the creation of this database instance. So you notice that database instance was actually created, and subsequently it just created one backup. We can restore the database from this backup as well. So this is the restore option, as well as we can delete the backup. So apart from that, we don't have any replicas. So there is nothing coming into the replica. So we can definitely create replica. But this read replica is not a standby replica. So when your database, primary database will be crashed or database is not available, so it will not be redirected to read replica. So read replica is basically used for to offload the database read. So whenever the client will connect to this read replica, the main database will not be bombarded with the connection. So that's the only reason this read replica can be created. There are other reasons as well. We will come those things later, and we will create the read replicas in the subsequent videos. And then the operations are coming into the picture, where the operations will be listed, like when the database was created, and then backups was finished, and then we created just now the users as well. All right. So now let's try to connect to this database, and let's see how we can connect to this database from an external client. So for that, I have already installed this dviewer. So dviewer is basically one database, a graphical user interface through which we can connect various databases like DB2, MySQL, MariaDB, Oracle, PostgreSQL, SQL Server, and there are lots other more. So for now, we are going to connect to this MySQL. Now we can go to this MySQL section, and we can provide this username, database user, and password, and other things. But just note that this we have created this database and have the public IP address. But is it okay? Is it enough to connect to this database, whether we are having this public IP or or we need to have something else. So there is a security comes in the picture with this Cloud SQL. So it's not only your public IP address that is needed to connect to this database, as well as your client should be whitelisted. Otherwise, unless your IP address from where you are actually accessing this database is not whitelisted, you cannot connect to this database. For example, to have this proved, we can copy this public IP address and we can go ahead and provide this server host as the database host name, and we can provide the uh, password that was generated at that time. I have copied this one and just provided this one, and then I just click finish, and then it will try to connect to this database. Now, okay, first it is trying to download this driver. So let it download this driver because I don't have this driver of MySQL to connect to these MySQL databases. So it will first download this driver and then it will try to connect to this server. But eventually it will fail because this particular IP address, I'm connecting this database from my local host. So from my local server, my local laptop. So this computer's IP address is not whitelisted, so it's connection timeout. Okay. So we can see the first link. We can just click the first link and we can see that it is saying my public IP is, as well as we can verify this IP address in from one other link, and it is detecting my IP address, which is exactly same. So it is saying that exactly same IP address. So what we will do, we will go to this MySQL dashboard and we can go to this connection section and let's go to this networking, and over here we are going to add our network, and maybe I can say my computer as the name of this my network, and I can provide the IP address of my laptop. Now let's save this configuration. So once we do so, it is trying to edit this MySQL instance, and it is going to whitelist our computer uh, to connect to this MySQL database server. All right, so our network is actually saved. Now let's go to this client and now let's try to connect to this database. So this is going to connect our database server, and now you can see this particular computer as it is whitelisted. We can see the databases. So we are having these databases over there, and we can create the database. Even we can just right click and create a new database. We can keep a database name as my first DB, and we can create the database over there. So this particular database is created, and we are trying to access this particular database from our local host. All right, so this is how we can connect to these database externally. All right, so now let's switch our gear to connections. So what we will do, we will actually disable the connections of the outside world. And what we will do, we will actually enable the connections from private IP only. So we can disable the public IP. So whatever the public IP access we do have from our local computer, we are going to drop this one and we are going to enable the private IP. Now, once we enable the private IP, you need to associate some network. Okay. So right now we are having only one VPC, that is default VPC. So we can select the default VPC. So any computer or the VM machine or any Google Cloud resources that is under default network can able to communicate with this connection through private IP. So that is why we need to ensure that this particular Cloud SQL instance is associated with some network. So we have selected the default network, and now we need to set up the connection. So we need to first enable the API. So this API is for service networking. So within the services, this API will help to communicate. Now, either we can provide a range of IP address, or we can automatically ask Google Cloud to assign a IP range. So basically, if we want to specify some IP range from which this internal IP address will be created for this MySQL database, then we can manually select the IP address and we can allocate a new IP range. Otherwise, we can ask the Google Cloud to automatically allocate some IP ranges. So I am fine with IP ranges that is being created by Google Cloud, and let's create connection. It will take some time. So once it is done, we will come back. Let me pause my video till then. All right, so our private access is actually set up. So now the default network, within this default network, it can assign some private IP, and that IP address will be assigned to this MySQL database. So now let us save this one, and again, our database instance is going to be edited. So it will take some time. Let's wait for some time for that, and I will come back. All right, so our private IP is actually enabled right now, and we have disabled the public IP. So let's go to this summary section, and we can see right now we got one internal IP address and our public IP address got disabled. So it's very natural that we cannot use the same public IP address that we use to connect to our local DBR client. So through this particular internal IP address, we can only connect to this database within these Google Cloud environment. So what we will do, we will quickly create one VM instance in the same default network, and we will use the internal IP address of MySQL database that we have created to the internal IP address. So I am not actually interested about anything. So maybe I can allow the full access, and I can go to this advanced option and make sure that networking is using the default interface. So basically, default VPC should be selected. So we are going to create the VM instance within this default IP. So that's it. So once the instance will be created, we will come back. So till then, let me pause my video. All right, so our VM instance is ready. So let us connect to this database, connect to this instance. So let us do one thing. Let us go to root, and we can clear the screen, and let's try to install the MySQL client. So maybe I can say apt-get install default MySQL client. It's already installed actually. So let us see what is the version of MySQL client. So we can say MySQL minus version, and we can see that it's 15.1. So we can clear the screen, and let us go to this MySQL dashboard and grab the IP address. So this is our private IP address. Let us copy this one, and let me try to connect to this database. So -8 needs to specify to the IP address, and then our user is root, and I need to provide the password that was generated automatically when the instance was created. So bang on, we have connected to our MySQL client, MySQL database server. hosted on Cloud SQL. Now we can see one of the databases over there. So we created one database which is my first DB, which is actually still over there. So we can connect to this my first DB, and we have connected to the database, and definitely there was no tables. So show tables, there is no tables, and definitely we can create one table from here, create table T1, and we can specify uh, employee as character 30, and we can say employee ID, which is integer. And we can insert some value on T1. We can say John, employee ID is 10, and we can say Harry, and we can select the data from these table as well. All right, so in this way, we can interact with the database. So let's now exit from this MySQL console, and let's do one thing. Let's connect to this with user one that we have created as a other user. And now we have connected with the user one. So this user one we created from the console. And let's use this database, my first DB, and let's see whether we can connect to the database and select the table that we just created from root user. So we can see the database is accessible and the table T1 is accessible from user one user as well. Now let's do some testing. Let's try to create some table space in this particular database. So let's try to create the table space. So for that, we are going to use the InnoDB engine, and we can say create table space TS1, add data file TS1 IBD for the engine InnoDB, and we have successfully created the table space. Let's create one table T2 inside this table space. So definitely we need to use the uh, database. We need to connect to the database that is my first DB that we have created earlier, and then we are going to create the table inside the table space TS1. Now we can create another table, and this time the row format should be dynamic, and we have created the table T3 as well. Now we can create the table space T2, and this time we are going to provide the file block size at 8192, that is 8K page size. And we see that TS2 table space is also created, and we can create the T4 table inside this table space. So create table T4, and you are going to specify the table space is TS2, and the row format is compressed. Now all these tables are created and table spaces as well. Now let's create one undo table space. So create undo table space, add data file undo IBU, and the undo table space is created as well. All right, so now let's go to the database console, and we can see in the under the system inside right now, if we have select this 1 hour granularity and this 1 hour time frame, we can see some events and occurred like the CPU utilization and the disk utilization. We can see some matrices are coming. So we can see at the different time the CPU is utilized, how much CPU, and we can see the how much CPU utilized, and we can see the read-write operations, we can see that how much read and how much write has happened. So we can pinpoint the data transfer in and out. So um, database connection, we only have one connection, so it's completely fine. We can see the database load got picked up when we created so many table spaces and tables and all those stuffs. And you can see um, each and every granularity, each and every operations are being logged. Disks usage by type, so it's a kind of a different metrics, how much disks is used, and whether it is a bin log, whether it is a audit log, or it is data. Even you can just check the data. I mean, when I click this one, this came over here. We can see general log, we can see temp log, temp data. So the query latency, like how much latency we are having right now. I mean, the maximum was 1 second, which is pretty good. And we can see the InnoDB pages, memory components, InnoDB data, fsinks. So, which is basically number of InnoDB fsinks calls per second. And even if we click this I option, you can see that this is how these filters are actually working. So MySQL queries, you can see that the queries, how much latencies were there, how much time it lags for each of the queries. Click a time series. So then MySQL queries, MySQL table definition cache. So all the cache are being used or not. So you can have the deep information about that. So data dictionary, how much memory was utilized. So all these kind of metrics have come, and you can definitely customize your dashboard. So you just click it, and you can drag it, and you can position it in different places. You can make your own dashboard, and you can name your dashboard as well. So you can definitely do that. And as well as we can see that the users that we created over there. So in the next upcoming video, we will create one IAM user as well, where we can use that IAM user to communicate with this database directly. And also we will see how the replicas will be created, and how these replicas can be cascade the data to the replicas, and how we can retrieve the data directly from the replica without touching the actual primary or standby databases. Also, we will see how we can change the database to multi instance database, so that uh, we can use the failover whenever there is an issue in the primary database itself. So thanks for watching the video. It was all about the MySQL Cloud SQL database. And in the upcoming lecture, we will go deep inside MySQL Cloud SQL database, where we will create the replicas, and we will play around replicas, and we will create, or we will change the database to a multi-zonal database, so that failover can be flavored as well. So thanks for watching this video. See you in the next lecture. Till then, goodbye. Stay safe.